Hello again, students. Today I'm going to give you a very quick two-dimensional shape review. A lot of this should be review from 6th and 7th grade. You may already know most of it, but it's important that we get a quick catch-up and refresher on how to find the area of two-dimensional objects before we can find the area of three-dimensional objects. So again, this will just be a quick study session. If I move too fast during this, come see me during class and I can give you some extra help. Okay, so for this review, we will be going over how to find the area of quadrilaterals, triangles, trapezoids, and circles. Let's begin. So when I say quadrilateral, quadrilateral, as we know, is a four-sided object. For this review and for this unit's purposes, the quadrilaterals I am talking about are squares, rectangles, rhombuses, and you will remember a rhombus just looks like a squished square. So all the sides are equal just as a square would be. And the last one is a parallelogram, which looks, as I draw this very poorly, looks like a squished rectangle. So my top and bottom are the same, and then my two sides are the same lengths as well. So squares, rectangles, rhombuses, and parallelograms are my quadrilaterals. Now, in order to find the area of a quadrilateral, all we do is base times height. I give an example on the board. I have a square. Say my height is 3 and my base is 3. I just do my base 3 times my height 3, and my area is 9 units squared. Remember to square all of your units when we are finding area. So just as a quick practice, you may posit my first shape is a square, and it's 2 by 2, and my second shape on the bottom, let's make it 3 centimeters by 4 centimeters. So please pause it now and find the area of these two quadrilaterals. All right, a quick refresher again, my area A equals base times height. So I have on my first one 2 centimeters times 2 centimeters, and my area is 4 centimeters squared. Again, don't forget the square. On my bottom one, I have 4 centimeters is my base, 3 centimeters is my height. 4 times 3, I have an area of 12 centimeters squared. You would use this same equation for rhombuses and parallelograms. Again, if you need extra help with this, come see me in class, but I think most of us have this mastered. Next is my area of a triangle. So this works for any triangle, equilaterals, isosceles, there we go, found the word. And all my triangles, right triangles, this equation works for all of them. So my equation is my area is 1/2 base times height. Where we get this from, and if you ever forget how to find area of a triangle, just remember, any triangle, no matter how I draw it, is half of a square or a rectangle. You can kind of see that from my drawing right there. Any triangle is half of a square or a rectangle. That's why we do the base times the height, and we take half of it. So I'll do an example for you. Here's my first triangle. Let's say my base is 6 and my height is 8, and both of these are meters. Again, my equation is A equals 1/2 base times height. So on this one, I would do the base times the height, which is A equals 6 times 8, which is 48. And then don't forget to take half of that, because a triangle is half of a square or a rectangle, and my area would be half of 48 is 24. That's 24 meters squared. Please try this triangle over here. Let's put the base of it as 7 and the height as, let's go 8. And both these will be meters. Please pause your recording now and complete these. All right. Again, I begin with my base times my height. That is 8 times 7 is 56. And then I take half of 56, which would be 28. So 28 meters squared. If you have weird numbers, another method that works for people is you can just take half of one of the sides. For example, if I were just to take half of the 8 right here, half of 8 is 4, and then I would take my other side, 4 times 7 times my base, and that also will give me 28 meters squared. So you can times them both together and take half, or you can just take half of one of the sides, whatever floats your boat. Our next shape is the trapezoid. The trapezoid is one that it seems that most students have the most difficult time with. So our equation, as you can see right here, is A equals 1/2 of the height, and then in parentheses, base 1 plus base 2. I know it's kind of an intimidating equation, but it's really not that bad. So I'll give you an example on the board. Let's say my top of my trapezoid, as you notice, my bases, my top and my bottom base are different lengths. So let's say my top base is 3 inches. And my bottom base is 4 inches. And the height of my trapezoid is also 4 inches. All right, let's just plug numbers into the equation. So I have 1/2 of my height, which is 4 inches, and then in parentheses, my bases. So it really doesn't matter which order you put them in. So let's say my first base is 3, and my bottom base, my second base, is 4. Now, if you remember your PEMDAS, you will notice that we have to do my parentheses first when solving this. So I have to go with the 3 plus 4, which is 7, and then I can just bring everything else down. 1/2 times 4, and then since there is no sign between the 4 and the parentheses, that is a times as well. So I have 1/2 times 4 times 7. 7 times 4 is 28, and 1/2 of 28 is 14 inches squared. Again, we're doing area, so don't forget your squared. And also, if I was doing the 1/2 times 4 times 7, I could just also take half of one of those numbers. So half of 4 is 2, and 2 times 7 is 14. Whichever way you do it, it'll get you the correct answer. All right, so I will give you a chance to test this out, see if you know what you're doing. Again, my equation is A equals 1/2 times height, in parentheses, base 1 plus base 2. So add the bases together and then solve it. For this trapezoid, my first base is 7. Let's go meters. My second base is 9 meters. And my height is 6 meters. All right, please pause your recording now and solve this. Welcome back. So I have my equation. Let's just plug numbers in now. A equals 1/2. My height is 6. In parentheses, my base 1 is 7. My base 2 is 9. Again, it doesn't matter which order you put those in. So I will start with my parentheses. 7 plus 9 is 16. So 1/2 times 6 times 16. And this one, I'm just going to take half of one of my numbers because that's easier for me. So I'm just going to take 1/2 of my 16, and that becomes an 8. So my 8 and my half are, excuse me, my 16 and my half are knocked out. And then I'll bring down my 6. 6 times 8 is 48 meters squared. If you were to do 6 times 16 and then take half of that, that will also give you 48 meters squared. That is how you do trapezoids. Before we get into area of circles, it's important to know your vocabulary. So this poorly drawn circle demonstrates everything that we need to know vocabulary-wise for a circle. A circumference, when I say circumference, that is your distance around the circle. Diameter is the straight line that goes from one end, passes through the middle of the circle, and then goes to the other end. My radius is exactly halfway through the circle. It is important to know that if you double the radius, you have the diameter. And then my last one, which we actually won't be using today, but we will later on, is the chord, which is just a point that passes all the way through the circle, but does not go through the center. So don't worry about that today. The big thing to know is your diameter and your radius for area of a circle. For my area of a circle, I have A equals pi r squared. That means the area is equal to the pi times the radius squared. So in M25, we use pi is equal to 3, just for a nice round number. We know that pi is 3.114, etc. But for this test in this class, we're just going to use pi is equal to 3. So let's say my radius for this first circle is 4 inches. Again, radius is halfway through the circle. Using my equation, I'm just going to plug numbers in. So if my area equals pi, again, we're going to use 3 for pi, times the radius squared. My radius is 4, and that is squared. Again, remembering your PEMDAS, you will notice that you need to solve your exponent before you do your multiplication. This is where most students get mixed up. Do your exponent first. So A equals 4 squared is 16. Bring down my 3. 3 times 16 is 48 inches squared. I will stress that again because it is important. Do your exponent before you do your multiplication. Please pause the recording and complete number 1 and 2. For number 1, again, A equals pi r squared. We are using 3 for pi, and then my radius is also 3 squared. 3 squared is 9. 3 times 9, my A is 27 yards squared. For my second one, again, A equals pi r squared. We are using 3 for pi times r, that is 10 squared. Doing my exponent first, 10 squared is 100. Bring down my 3. 3 times 100 is 300 millimeters squared. If you got both of those, congratulations. You are good to go on circles. All right, I know we rushed through that a little bit, but that is the end of our study session. If you need additional practice with these, for quadrilaterals, that's our 4-sided, that's our squares, rectangles, rhombuses, parallelograms, every 4-sided shape excluding trapezoids, please do page 444, numbers 1 through 3. If you need additional help with triangles, page 444, numbers 4 through 6. Help with trapezoids, page 444, 7 through 9. Or circles, page 450, numbers 8 through 10 for area. My name, number, and email are at the bottom if you need anything. Have a wonderful day, and I hope to see you soon.